We can begin this discussion by talking about what parallelism means. And in order to create parallel processes, we have several units that modify same resulting output. That means that you have many segments of a particular process which can independently work and then merge together to give you a resulting output. All of that needs to obviously be synchronized and communicated properly to modify the result. But basically that is how parallelism works. Sorry. Now we can look at what programming paradigms currently exist and which ones allow it. So with we have four basic programming paradigms with the ways to create software that is. First is procedural. Is basically it's a program where like you can create programs that are a list of instructions. It can be like C or C++ where you have to follow a particular sequence to write. Like you have to have header imports and stuff. In declarative, you can have languages that figure out how to perform computation within the statements that you write. So this is like SQL, like you tell the computer which segment of the data set you want to select. You can have object oriented, which is manipulating the collection of objects, for example in Java, in order to carry out some functionality. And the last is functional programming paradigm. So this one creates, it decomposes the big problem into a set of functions, and it applies that set of functions on the input that it receives. So it is something like using lambda function in Python. Modern languages will support more than one paradigm anyway. So in the functional approach, you have to apply function to arguments. Your functions will be able to take some input and produce an output without any side effect, which means it should be defensive, like it should not give you an error in between. It should be high order function, so it should return a value of a function or a function, and it should have no mutable data structure, so it should only be working on fixed values and functions. The advantages of this is that it is debuggable because the data set is small, it can be unit tested, and it has a property of composability. So that is a separation of concern. Now, how this allows us to work with map, reduce, and filter functions is that, okay, of course, we can start by describing what map, reduce, and filter means. So map is about applying a function to every element in a list that you provide. Reduce tries to collapse all these elements into using some function. A filter tries to, of course, filter some elements from a list. It's basically like selecting which ones you want to work with. So the output of map will give you a list which is the same length. It just applies a function to everything. And with reduce, you will receive just a one element output. And with filter, you can receive either equal to or less than the length of the input list. So this is an example of how we are using function of summing the list or providing an exponent function to a list, mapping that, and trying to reduce it in this particular example. We can also we can also chain multiple map and reduce calls to scale up the functions. So we can, so this is basically what HDFS is trying to do, which is Hadoop distributed file storage. It tries to split the data file into multiple blocks. It distributes it in clusters. It keeps 3 copies for redundancy, of course, and then it brings computation to the data. So your entire function will be reduced by like your data set will be reduced by the functions being applied on them in each cluster. So your architecture in HDFS is composed of 2 major things. One is a name node, which is a master server. It manages the file system namespace. It regulates the access to the file and carries the meta information. It can be the replication factor, for example, like how many replicates of that particular cluster exist. Then it also has data node. That's the second component of the architecture. So there may be multiple data nodes, and it may have and it obviously stores information about the data set. So a failure of the data node can be identified when no, like every name node has to respond by something that is related to a heartbeat of the data node. So we can identify which one is not working properly or if it's broken. We should also be working on optimizing strategies on this. A limitation of HDFS is that the distributed file storage plus MapReduce is not flexible, as it only allows the map and reduce functions to work. And we also have to develop a lot of boilerplate codes on top of it. So we can have a distributed computing framework which computes tasks in graph format, and the users define the task, and all of it happens in parallel execution. An example of this is Dask, which we have worked on in this video lecture series before, and it allows parallel compute graphs, and it executes over the clusters, and it works with Python, supports the provision of a data frame.